Hello everyone. Today I am going to discuss about fault and what are different types of fault. So in this video I expect that you will learn about different types of fault, and also I will discuss about how to identify a fault in the field. And you can say what are the marker bed or what are the points that we should check in the field so that we can identify a fault in field. So what is fault? I think everybody should know that what is a fault. Now it is a simple fracture discontinuous surface along which the blocks are actually moved away from each other or along each other. This is called the fault. So here you can see a block diagram where the two blocks are there. In left side this is a block and another block is this one, and this plane is along which this is a discontinuous surface along which the blocks are moved pass to each other. So this is called as a fault. Coming to second slide, so here in this field photograph, you can see a fault marked over here. So this is a type of fault in which we can see that the beddings in the rock surface, in the rocks which are present earlier, are displaced with respect to each other. This is a black color bedding strata, and in the opposite side of the discontinuous plane, there is another bedding of the same bedding that is also black in color, which are offset with respect to each other. So this is a surface, discontinuous surface, which is separating to a same bedding bed or bedding plane with respect to each other, and it causes the offset of the bedding. So this is one fault where you can find in the field by observing the displacement of the or offset of the bed. So what are the components of the fault? So the faults have two components, throw and heap. Throw is the vertical component of the displacement. Suppose this is the bedding FW, this is the HW. HW stands for hanging wall, and FW stands for foot wall. Hanging wall and foot wall means the foot wall, the block which is actually moved up with respect to the fault plane is called as foot wall, and which move down with respect to the another block is called as hanging wall, and this is the fault plane. So this is the fault, and this is the vertical component of the displacement. So this part is called as the throw, and the horizontal component of the fault, where you can see that is BC, is called as heap, and AP here is called as throw, and BC is called as heap. And the head, what is head? Head is component that is nothing but the angle of inclination of the fault plane with respect to the vertical component, that is called as head. So here this is the angle BAC is called as head. Okay, so the parts of the fault that I have already discussed: what is the fault plane, what are the hanging wall and foot wall, what is head, what is throw, and what is heap. So fault plane, this is the fault plane or the field. You can see the fault graph with respect to which the portal and the hanging walls are moving away, or there is a offset of the bedding. This is the irregular bedding. On the offset of the bedding, you can see in the section. And this is the hanging wall and the port wall. I have already discussed. The down thrown block is called as hanging wall, and the up thrown block is called as the port wall here. And head, throw, and heap I have already discussed. Head is the angle of inclination of the fault plane with respect to the vertical component, and throw is the vertical component of the displacement, and whereas heap is the horizontal component of the displacement. So what are different types of fault? So here today we will discuss about the normal fault, reverse fault, thrust fault, vertical fault, what is host, trench, what is deep slip fault, and strike slip fault. What is the difference between the strike slip and the deep slip fault, oblique slip fault, then steep fault. The normal fault means it is very simple type of fault when there is any extension occur, like when the tectonic faults actually moving away from each other. As a result, a rupture or a fault surface developed in which the hanging wall portion actually moved down related to the foot wall. So we can say if the hanging wall moved down related to the foot wall along the fault surface, that is called as normal fault. Here you can see the diagram. And what is reverse fault? In the case of the reverse fault, if the hanging wall, offset of the hanging wall that actually move up with respect to the foot wall, in this case it is called as the reverse fault. Here you can see the same bedding which lie below actually now come over because of the reverse faulting. This type of faulting is called as reverse faulting. Now, what is the difference between a normal fault and reverse fault? So, if the hanging wall move downward and there is a gap in that bedding, and you can see in say in the field there is a offset that is called as normal fault. But in case of the option hanging wall moved up relative to the foot wall, then the bed will appear at the above. So, in this case, it is called as normal fault, reverse fault. Then thrust fault. A thrust fault is nothing but it is a kind of the reverse fault. If the angle of thrusting or if the angle of thrusting is very low, like the 20 degree to 30 degree around, in that case it is called a thrust fault. Otherwise, if the angle is greater than 30 degrees, suppose that is called as the reverse fault. Then vertical fault. So vertical fault is a simple. The fault plane is, as the name suggests, the fault plane is vertical in nature, and the and hanging wall block move down related to the foot wall block. So this is called as a vertical fault. Host fault. The host and graben is a type of the structure in the geology, particularly in the structural geology. Here, if the here you can see the host. Host is the elevated part where the which is bounded by two normal fault. Okay, and the towards the foot wall that is towards the top, and the hanging wall which are moved down in the both side, and it is both side it is bounded by the normal parts with a dipping away from each other. In that case, it is called as horst. And in case of the graben, what is graben? Now suppose this is two normal parts which are dipping towards each other, and the part of the block is called as the hanging wall that is called as graben. So this is a post and graben structure. So you can see the field photograph here. There are actually two faults, normal fault dipping towards each other, and this is the hanging wall block which is moved down relative to the foot wall block. So this is called as the graben. And the right side and the left side part, this foot wall portion will be called as the hoist, and the hanging wall portion will be called as graben. So this is the same like graben, horst and rift structure. And now coming to the deep sleep fault. So what is deep sleep fault? Okay, so deep sleep fault means if the movement of the hanging wall block along the deep direction, either towards top or towards top or the bottom, towards up or towards down, towards up or towards down. In that case, that is called a deep sleep faults. Similarly, in case of the strike slip fault, if the movement of the footwall and hanging walls along the strike of the fault line, that is called a strike slip fault. In the deep slip fault, it is along the fault line, down along the deep. In case of the strike fault, it is along the strike. In case of the oblique slip fault, it is neither towards the tip, neither towards the strike, but at an angle with respect to the strike and the dip direction. So here you can see the hanging wall which is actually moved. If you connect the edge of the corner of the block, then it's moved at an angle with respect to the strike of the fault and at an angle along the dip direction of the fault. So this is called as oblique slip fault. The step faults means if there are a number of series of the normal faults which are occurring together, which are parallel to the each other, the fault surface, then in this case it is called as a step fault. In case of the parallel fault, so in this case it is also same a series of the fault, but they are more or less parallel to each other. So this is called as parallel fault. Evidence of faulting. So how do you identify the fault in the field? So this is the basic concept that every geologist should understand, that you are going to field and you have to identify the fault and what are the evidence. So what are the evidence you will look for, and that thing you should know. So first thing is the lithological evidence. You can identify based on lithology or physiographic evidence, because in everywhere the lithology is not visible because of the soil cover or something. But if you look after the overall physiography of the area, so there are some indication about the faulting. First thing is histological evidence. So if you find a Schlicken site, so Schlicken site means nothing more. So this is the fault surface, and movement is the suppose the deep slippers, and you can find the line-like feature over the surface. It is called as the Schlicken site. And fault brexia and gauge, because of the faulting now along the fracture surface, so there are very fine kinds of brecciation takes place, and small fragments are produced because of the faulting, because it is a different brittle kinds of deformation. So that is called as polymorphia. And these two are differentiated on the basis of the grain size. Okay, then drag. Suppose the faulting occur and the down hanging wall portion is dragged the footwall portion like this, and in this case it is called as a drag fault. Then a dislocation. So dislocation means that is the offset, nothing. Repetition or omission bed. Suppose the normal faulting occur, and there you can suppose a fault is there. Suppose this is a outcrop. I am drawing here. So this is a outcrop, and this is a fault. So this is a strata which ends or abrupt suddenly at a particular place. Beyond that, it should continue, but there is no evidence of the same bedding continuity. So in that case, you can guess that, or you can find the evidence that there is a faulting. Most probably, this is a kind of fault. Okay, the silicification and mineralization. So fault plane actually acts as a good pathway for the movement of the hydrothermal fluid or any kinds of fluid is water. So if there is any silicification and mineralization or intense silicification and mineralization along the surface or close to the along at a particular zone, you can guess that we can get evidence that there is a possibility of the fault present in this zone. So these are all the things that I discussed already. You may take a look or read after that. Then what are the physiographic features? So physiography you have to look in a broad scale. So fault scarps. So fault scarps are nothing but suppose this type of truncation you will find. So in the ridge, suppose this is the ridge and this is the valley. So if there is any fault happens, so this type of truncation you will find. This is a triangular, nothing but triangular shape of surface which move about which you can see about the surface, and that indicate that there is something abruptly end of this topography or the geology. So this is your indication of the fault scarp, and the fault line scarp is also same thing. So is there any small ridge or small depression like things, you can say that this is the fault line scarp. Support control over the stream. So stream is actually stream. So suppose there is a stream going like this, not only it drive out like this. So there is a possibility that across this the faulting has occurred. That's why these streams are actually offset. You can notice. So this is one example of the evidence of the fault. Thank you. I hope you like the video. And if you like to get any types of video related to geology, you can simply comment on the comment box so that I can prepare that video for you. You can freely type anything you want to understand, anything you want to learn. You can just type the topic of the subject. I will teach you. Thank you.